Hello, welcome to Statistics 1 course. And this week we are going to look at Chapter 2. In Chapter 1, we just studied what statistics is and what we need statistics for. And in Chapter 2, we will look at in detail what the data is and how do we measure data. And we will see some examples of collecting data through questionnaires. We collect data, and the collection of data is very important because if you make any mistake in collecting data, and those mistakes will be reflected in your reports or your analysis later on. So we have to make the best out of collecting data. So how do we do it? We have to use statistical methods to collect our data. And the data set comes from different forms, as we talked about last week. And as you know, in social networks, most of the time data is pictures and videos. But in the street, the number of apples you sell or the number of eggs you sell is the data. So we have some main ingredients of the data. So here is an example data set from your book, table 2.1. And what we see here, we have 1, 2, 3, 4, 5 objects or cases. And we know their names, and we know their genders, and we know their age, and we know their weekly wages. So these are weekly wage, age, gender is name is the variable we are interested. So different characteristics of the objects or cases is the variables here, as you can see. And each data point is an observation. So we call this one an observation. Is the value of a case for a specific variable. So the fifth person in our data set is Stephen, and the variable is age. So we know that the age of Stephen is 38. So we have to identify these characteristics. So we call these different characteristics of the data set as the variables in our data. So one of the difficult questions is can we classify how we measure data? And it has been a very long dispute. And around 1940s, and Stephen introduced a system. And in this system, we have 4 different scales of measurement. And this comes from lowest scale to the most complex scale. And it starts with the nominal scale. Nominal scale is the lowest scale of measurement. And what we do in nominal scale is we just classify the results like male and female. So there is no ordering in the data. We only have categories. The color of your eye, brown, green, blah, blah. Or the name of the horses in a horse race. And you know the name of the horses might be very different in horse races. So we just have, in nominal scale, we just have categories, but these categories can be ordered in any way. So male might be the first and the female second, or female might be the first and male might be the second, but not in ordinal scale. Ordinal scale is still useful for qualitative measurements. It's very similar to nominal scale. We have the categories, but this time we can somehow classify and order our data. Okay, the easiest example comes from, again, horse racing. At the beginning of the race, as you know, all the horses are on the same line, and on this same line they are randomly scattered around and they have names. But once they finish the race, now they are ordered. We have the number 1, number 2, number 3. But the difference between number 1 and the number 2 is not equal most of the time to the difference between number 2 and number 3. So in ordinal scale, even though we can make an order, the differences of the ordering might not be useful. So in ordinal scale, we have categories, but these categories can be somehow ordered naturally. But in the nominal scale, we cannot just naturally order them. And interval scale, we have now classifications, but now we have magnitudes and we have equal intervals. And the easiest example is the temperature. We can measure the temperature with Fahrenheit or Celsius scale. But the biggest problem with the interval scale is we don't have an absolute starting point. And in Celsius scale, 0 is a starting point, and it says that it's the data point where the water becomes solid to liquid or liquid to solid. So it's the state of the water that defines the starting point of the Celsius, but the corresponding Fahrenheit value is a different number. So there isn't exactly a starting point, but there is equal intervals. So between 1 centigrade degree, 2 centigrade degree, and 3 centigrade degree, we have equal intervals in interval scale. And the ratio scale is the most sophisticated or the most complete scale of measurement. And this time it's like an interval scale, and we have equal intervals. We can make magnitude to be measured. It makes a classification, but at the same time we have a 0 point. And what I mean is there's a specific starting point in ratio scale. So if I tell you that you have no money in your bank account, it doesn't matter it's a Turkish lira or euro or dollar, you are broke. Okay, so I'm sitting now here, and if I say to you I moved from my position to the left 0 centimeter, 0 millimeter, and 0 kilometer, it means the same thing. I didn't move at all. So the ratio scale has a very specific starting point, and the ratio scale allows us to make comparisons, division and multiplications, those of things. So it's the most complicated level of measurement. And as we told about before, we need to collect data. So how do we get this data? It's not easy process most of the time. There are laws to collect data, and you have to get lots of permissions to collect data. But there are some different data sources, and these data sources might be the internal data sources, such as you are working in a company, you are the sales manager, you already know your customers, and you have the database in your hand, and you can just look at the results of the previous sales, and you can just use this internal data. But let's say again you are working in this company and you need to enter the new country. Okay, if you want to enter this country, you need to know what kind of customers you might have in that country. So what you are going to do is you will ask someone else to give you a data about the customer type in your new country. So this is the external data source. Maybe sometimes you will use statistical books. You will go to the library and you will look at the old reports, government reports and other reports. Then you will see if you have the data in your hand that you are going to use. So we can either use internal data sources, which you will do everything, and maybe you can outsource your data needs and use external data sources. And how there are different methods, like we have observational study. We just collect data based on what is seen, heard, and inferred based on the data collect. Research objects, subjects, and measure variables of interest without any intervention of the subjects. And in experimental studies, what we can do is we can manipulate some of the variables. Like you are trying to grow a tree in a specific environment, or you are trying to adapt a tree to be grown some area. So what you can do is in a laboratory, you can create this environment, and you can make some simulations, try to change the heat in the room, and then you will look at the reaction of this tree. Then you can understand if it's going to be available or fit to be grown in a specific area. Okay, so you try to control some of the variables and try to see the results of other variables. And sometimes you make observations. What this can be is, let's say you are trying to hire new employees, and you put the people into a room and you open up a discussion and they will discuss each other a specific subject and you will just listen them. Okay, so this is going to be your observation. You will take the behaviors of those people and maybe you will see the result of the meeting and you will take some notes about what is going on and which employee is more suitable for your company. And another data collection method is interview method. And in an interview method, you will come face to face with a person, and but time to time, face to face doesn't mean you need to see the person. Maybe you can make a phone call, but you will have one-to-one connection with the object. And another method of collecting data is self-enumeration. In this method, what we do is we create a form, and most of the time we call it questionnaire, and we put some specific questions in it, and this questionnaire is given to you and you read the questions on your own time and you just answer the questions whichever you find suitable for a specific question. So this is another method of data collection methods. So when you are in self-enumeration method, you have to be very careful with the questions you are asking, and there are lots of different type of questions, and those questions are based on what you are going to need in the future. So there are different questions in a questionnaire, and one of them is open-ended or closed-ended questions. What you do here is you ask a question and you let the person to give their answer freely. Okay, and it will take time to analyze these kind of questions because people will write the same situation in many different styles, so you have to understand what is going on. So these questions are very good to collect data, but to make an analysis it will take time. Or we have single or multiple responses. Which of the following vehicles do you use to go to school? So there are different choices here, but maybe some days you are going with bicycle, some days you prefer bus, so you will choose two of them. Okay, so single or multiple responses. Time to time you can force your people in your survey to choose only one of them, but you have to write down this question carefully, saying that answer the following question by making only one choice. Ranked responses. What might happen is sometimes you need to collect the preference of people about something like films. Okay, so what kind of films you like and give your preference levels, and when you give these preference levels, maybe the company in the future will give you offers with the score highest. If I prefer action movies the best, maybe the company will give me some discounts on action movies. And sometimes we have rated responses, and there will be a sentence saying that if you want to go home, I prefer metro. Okay, so this is the sentence, and you will choose are you agree, strongly agree, or disagree. So you don't use metro all the time, so you can directly say strongly disagree. Maybe the metro is not available in your area. So sometimes we have rated responses. And when the data comes in any form, it's not organized, and we call it raw data. This is the data as you collect it. So if you are working in a company and listening to this program now, what you can do is look around you and ask the people around you how old they are, and you just collect the data: 27, 28, 25, 24, blah blah blah. So as you can see, we have just the data points, and those are the ages of the people around you. So we don't make any manipulation, it's just sits there as it comes. So we call it raw data. And if there are a few objects, it's easy to see what is going on with your data. So if there are 10 colleagues next to you, and if you will have 10 numbers of age, so it will be easy to identify what is the minimum age, what is the maximum age in your group. But as the data gets bigger and bigger, it becomes difficult to see what is the highest number, what is the lowest number, and if there is a middle number, maybe most of the data points are gathering around. So what we do is we create frequency distributions. So we find distinct values like strongly disagree in this example, and how many people said you are strongly agree with this sentence. 4 people. So frequency distributions are just counting of the categories. Okay, we find the distinct categories, and for each category how many people gave the answer, then we will create this frequency distribution. So how many times each category is repeated is shown by frequency distributions. In continuous variables, we have another distinction. We call it grouped frequency distribution. So if we have too many classes, and it starts here from 120 to 589. So if I want to create a frequency distribution and using the numbers like 120, 121, 22, 23, blah, 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 it will be a long list. So I don't want to see this long list. I'm trying to understand what is going on with my data. So what I can do is I can squeeze it into a group frequency distribution. What we do in group frequency distributions, we create groups like this. So this is a closed end and this is an open end. So it means that the observation values, which is weekly salaries, $120 up to 171.9999 is going to be in the first category, and whenever you reach $172 salary per weekly, you will be in the second category. So you will look at your data and you will create this grouped frequency distribution. So this is very important, which side is closed or which side is open, because the objects will be classified into a respective category. So if I have 172 salary weekly, I have to be in the second category because 172 is starting data point for the second class. And remember nominal and ordinal scale. In nominal and ordinal scale, we have categorical data. We have like gender, male, female, and the movie types, action movie, horror movie, blah, blah. And can I classify 2 variables into one table? And it's very easy in statistics. We call it contingency tables. In contingency tables, 2 categorical variables can be classified into one table. So we have here gender, female and male, and we have technical knowledge. They have technical knowledge, yes or no. Both of them looks like a nominal variables. And in total, we have 400 objects. And out of this 400, 170 of them has technical knowledge and 230 of them no technical knowledge at all. So it's very easy to see and make some descriptive statistics. So if I had these 400 observations in an Excel sheet, just writing down male, female, blah, blah, blah. Next to that, technical knowledge, yes, no, yes, no, yes, no. It was going to be very difficult to understand what is going on. But now, once you create a contingency table, it's very easy to see what is going on. Maybe you can make some other reports. Let's go back a little bit again. So we have in statistics, we need to collect data. And when you collect data, we need to identify the variables. Okay, what variable you are interested in. And we need to find observations to collect data. And we will ask these questions. Once you ask these questions, what you can do is you can create frequency distributions depending on the type of the data, or group frequency distributions, or if you want to make comparisons, then you can create a qualitative data for a contingency table, and using this contingency table, maybe you can compare to categorical variables. And see you next week. We will study chapter 3 in next time.